Hello everyone, in this lesson we will learn about matrices as one of the data structures in R. So by the end of this lesson, you will learn how to create matrices. Now, one more thing, this video is going to be long, but it will be worth your time, especially if you want to learn everything there is to know about creating matrices in R. A matrix is a rectangular array of numbers arranged in rows and columns. The rows and columns define the dimension of the matrix. And so the dimension is simply m rows and n columns, often read as m by n. So this is an example of a matrix A with a dimension 2 by 2. And this means this matrix A has 2 rows and 2 columns. If you want to create a matrix in R, you use the matrix function. And within the parentheses, you provide a set of arguments to create the matrix. Let's go to RStudio and learn how to create matrices. Now, here in R, there is documentation for every function you want to use. So if you want to get the documentation for the matrix function, you simply need to type the help function, and within it, you just type the name of the function for whose documentation you seek. So by writing help and putting in matrix, simply execute and you would find the documentation showing up here, and you can read a lot about the matrix function or how to create matrices as a whole. Another way you could have also brought up this documentation is simply to type the question mark symbol followed by the name of the function and just execute, and that would also yield the same result. So we have the topic here as matrices, and a description is given for how to create matrices. But most importantly, we are looking at usage. This is where we get to know the function and the various arguments that can be used to create the matrices. So by default, the data is set to NA. The number of rows, which is n row, equals 1. The number of columns, which is n col, equals 1. By row equals false, and dim names equals null. All of these will be explained in detail in this video lesson. So what you realize that these arguments are provided by default. So to first create our matrix, we'll just simply type the matrix function and pass in nothing in there. Just simply execute this. And you observe that the only value that is given in this matrix is NA, which is the default value that is given to the data argument. You also observe that the number of rows is just simply 1. The number of columns is 1. So this creates a 1 by 1 matrix where the only value present in this matrix is just NA. So this matrix function could have also been executed this way. We specify data equals NA, then n row equals 1, n col equals 1. In the meantime, we will leave out the by row and the dim names argument. So if I execute this code, you observe that that is the same result that we had when we executed the matrix function without any arguments. Now we will go one step further by this time passing a value to the data argument. So I will just simply go ahead and say data equals 45, and then n row equals 1, and then n col equals 1. If you now execute, we have a 1 by 1 matrix with the number 45 in there. So this could also have been achieved the same way by just simply removing the n row and n col argument, because they are still provided by default. You will still be able to get the 1 by 1 matrix where the number is simply 45 in there. Now, the numbers within the matrix are called elements of a matrix. So sometimes I will just simply be using either the word number or referring to them as elements. So take notice of that. So this time, let us go ahead and create another matrix where the data is simply 45, and then we will now set the number of rows to be equal to 2. So what is going to happen? Let's execute this, clear the console, and now we have a 2 by 1 matrix. Now we only supplied the n row argument to be 2, which means we just simply needed 2 rows for this particular matrix. But remember, the n col, which represents the number of columns, is just 1 by default. So this creates a 2 by 1 matrix. Unless, of course, you want to create, for example, another dimension of a matrix other than the default, then you could also go ahead and just simply type n row equals 2 and say n col equals 2. So this also creates a 2 by 2 matrix with the same number recycled as many times to fill the dimension of the matrix you are looking for. So we have a 2 by 2 matrix that we have created here. Now let's create another 2 by 2 matrix, but this time we will have to supply our own set of numbers to populate this 2 by 2 matrix. So in this case, the data simply should be set to a vector where we provide the 4 numbers that are needed to create a 2 by 2 matrix. So let me just go ahead and just simply type some numbers. So we have 4, -1, 6, 10, and then we would set n row equals to 2, n col equals to 2. So if we go ahead and execute this, we now have our matrix created 2 by 2, where we have these as the elements of the matrix that we specified from this vector that we supply to the data argument. You would also observe that these numbers are actually arranged by columns. So you would see that the 4, -1 was arranged 4, -1, then 6, 10 was also arranged 6, 10, column-wise. And that is because the default argument for the by row argument is simply false. And so let me just copy this code and paste beneath it. And I will just specify the by row argument and set it to false, just like we have in the default usage. So if you execute this code, you observe that that also yields the same result, where these numbers that you supply to the data argument are arranged by columns. So if you wanted to arrange by rows, then all you have to do is just simply change the by row argument and set it equal to true. And so if you execute, you will now observe that the 4, -1 would now be arranged by the first row, 6, 10 would also be arranged by the second row, but you still end up getting your 2 by 2 matrix, which defines the dimension of the matrix that you are creating. Let's go ahead and create another matrix where data is going to be, so let's just supply some arbitrary set of numbers. So 3, 90, -1, 4, 8, 11. How many numbers do we have here? 6 of them. So what can we do with this? We can specify the number of rows to be 3 and the number of columns to be 2. So we do have 6 elements for the 3 by 2 matrix that we are creating. So if we execute this code, we find out that we have 3 rows and 2 columns. Now let's create a 3 by 3 matrix. So we would have matrix function, then data equals a vector of a set of numbers. So let's provide 9 elements, which will be used to create our 3 by 3 matrix. So let's go ahead and provide those numbers. We set n row equals 3 and n col equals 3. And this time, let's set the by row argument to true. Now you see that the code is getting longer and longer. There is a way we will deal with it very soon. So let's go ahead and execute this, and we simply get the 3 by 3 matrix. So if the code is getting longer and longer, then what you would do is you can go ahead and just simply type the matrix function, and within the parentheses, press enter to break it to the next line where we have that indentation we talked about during our previous video. So in the end, we will just specify data equals the vector. So this time I will just go ahead and copy this over here and paste it there. Then comma, you move to the next line, specify the number of rows to be 3, and then you move to the next line, specify the number of columns to be 3, and then we have the by row argument set to true. So you can also accomplish the same thing by doing this, which is much easier to read and not too lengthy. Now, there is a type of matrix that is called an identity matrix. And an identity matrix is a matrix where the main or principal diagonal has the value of 1 and everywhere else is simply 0. So if we want to create that, we will just simply type the matrix function data equals a vector of 1, 0, 0, 0, 1, 0, 0, 0, 1. The number of rows to be 3 and the number of columns equals 3. Now let's go ahead and specify the by row argument to false, the default. Clear the console, execute this line of code, and we get the main or the principal diagonal having only the value of 1, and everywhere else is just simply 0. This is what we call an identity matrix, whose dimension is simply 3 by 3. If I copy the same code and paste it here and change the by row argument to true and execute, you do realize that the nature of the matrix doesn't actually change. And that is because this identity matrix is also called a symmetric matrix, which means whether you arrange by rows or by columns, it is going to have the same structure. Or, for example, if the first row becomes the very first column, the second row becomes the second column, and the third row becomes the third column. That means you are interchanging the rows and columns of the matrix. It will have the same structure, and that is another type of matrix which we have mentioned before that is called a symmetric matrix. At this point, let me go ahead and create another matrix and show you something very important. So we have the data argument equals, let's say, 23, 67, 100, negative 67, 0, 3, and the number of rows, let's set it to 3, and the number of columns, let's set it to 2. And let's also specify the by row equals false. Now, let's clear the console and proceed to execute this very code. So this is the matrix that we get to create, a 3 by 2 matrix with our own set of values that we set to the data argument. Now, what I want to really show you here is that if you go into the documentation, you realize that the arguments have been provided in a certain order. So data comes first, followed by end row, then end call, and then so on. So what is happening is if you provide the values to your argument, like for example, this vector to this argument, this 3 to this argument, then if you specify them in that very order, there might be no need to actually specify the names of the argument. So for example, I could just simply copy this code and paste it here, and I will just remove the argument names. So let's have it like this. That means all of these values have been provided in the very order as dictated in the usage in that documentation on that particular function. So what happens is if I execute this code, you end up getting the same result because R is intelligent enough to figure out that this very first value that you give is assigned to the very first argument, which is data. Then this 3 is assigned to end row, and this 2 is also assigned to end call, and this false is also assigned to the by row argument. So that is how it actually works. If you specify your argument in that very order, there might be no need to specify the argument names. But for the sake of simplicity and the fact that others can also read your script and know what you are doing, you could also go ahead and specify the names of the argument. But it is not a hard, fast rule. It depends on you. So what else can be done? If you actually interchange the argument names, then something bad is going to happen. And let me show you what I mean by that. Let's say I actually move this 3 to the very first place of that argument. So what essentially are we doing? We are just simply saying this 3 is going to be mapped to this data argument. Then the number of rows is going to be set to this whole vector, which doesn't make sense. But yes, if you execute this, you're going to get a result. It may actually not be the result you are looking for. Let's run that and you would see something really crazy. So that is exactly what really happens. So it is very important that sometimes you write the names of the argument. But one thing is, even if you mix up the argument in not the very order that is provided in the documentation, you can also go ahead and specify the names of the argument in whatever order you want. So for example, this 3 I know should be the number of rows. So I will just go ahead and write n row equals 3. Then for the second argument, I will just say data equals this vector, and this is going to be n call equals 2. And I would go ahead and say by row equals false. And when you do that and execute, then you rightly get the very matrix that you created from the beginning. So even if you mix up the arguments, but you carefully bring the argument names, you would still be able to create the very matrix that you are looking for. However, it is expedient that you normally provide the arguments in the very order that the documentation suggests. Now, you can also choose to create your matrix in R by specifying either the rows argument or the columns argument only. Let me show you how to do this. So let us go ahead and create a matrix. And so let's say data equals the vector of 12, 90, 89, -6. So we are going to create 2 by 2 matrix. So n row equals 2. Now, if you go ahead and execute this code, what do we find? We have a 2 by 2 matrix that we have created. R realizes that once you supplied the number of rows to be 2, it figures out there are 4 elements to the data arguments, and therefore 2 columns are needed to complete the matrix for which you are creating. Let's copy this code and paste it down here. And instead of the n row, I could also specify the n call without the n row. And if you execute, you're also going to get the same result. So you can go ahead and specify either the n row, n call. R will figure out how many columns you need to complete this matrix that has this number of elements if you specified only the n row argument. The same way, if you specify the n call argument, then R will also figure out how many rows you would need to complete the matrix given the number of elements that you provided to the data argument. So let's go ahead and create another matrix. So let's have matrix, the data equals the same vector. So let me go ahead and copy this and paste. Then I would specify the number of rows to be 3. Now, something very important also happens. There are 4 elements right here. Let's execute the code and let me explain to you what happens. So by executing the code, R actually presents a warning. And it says that in the matrix which you created, the data length, which is 4, because we provided 4 numbers or 4 elements, is not a submultiple or multiple of the number of rows. So look here, you provided the number of rows to be 3. Then R begins to figure out how many columns you would need to complete the matrix for the number of elements that you have provided. Now R figures out that the first 3 numbers would be used to fill the matrix by column. But then when it begins with the very last one for the second column, which is the -6, it realizes that it needs another set of 2 numbers to complete a 3 by 2 matrix. So what does it do? It recycles over the elements that you provided to the data argument. So it starts again with 12 and then 90 to complete the 3 by 2. So it is important that when you're creating a matrix, you simply get to know what matrix you are creating and the dimension that is needed for that matrix. Another useful thing in R is to create what we call a diagonal matrix. Now, a diagonal matrix is a matrix where you have values in the principal diagonal, but 0 everywhere else. And if you want to create a diagonal matrix, you would use the diag function, DIAG function. And you notice that that also has some default arguments. So how do we get the documentation for this function? Of course, we can just simply type question mark, then followed by the diag name of that function. Execute, and you would get the matrix diagonals documentation. So you observe that the very first argument is x equals 1 provided by default. The number of row has not been provided. So all we have to do is go ahead and just type diag x equals 1. Let's execute this one alone and see what we get. I actually don't know what you're going to get, but let's find out. So if I execute, I actually get 1 value that is being provided here. So this is simply a 1 by 1 matrix. So even though the number of rows was not specified by default, like the one that we had for the matrix function, and the number of columns also was not provided by default, it figures out this is just simply a 1 by 1 matrix. But the purpose of this is to create the diagonal matrix. So we need to extend it further. So what do? We just go ahead and say n row equals to and let's explicitly also provide the encall argument to be 2. So if I go ahead and execute this, we now get a 2 by 2 matrix where the main diagonal of the matrix, the principal diagonal, has been populated with the value of 1, which you provided to the X argument. Now, this is also called an identity matrix because an identity matrix is a matrix that has the value of 1 in the principal diagonal and 0 everywhere else. So instead of going back here to create it the way we did it before, you could also just simply use the diag function. And all you have to do, if you wanted to create a 3 by 3 matrix, then just simply change the number of rows to 3 and the number of columns to 3. And if you execute, you would get your identity matrix with a dimension 3 by 3. But one thing is, you can use the diag function to create not just identity matrices, but just diagonal matrices. So for example, I could say x equals 4, n row equals 2, and then n call equals 2. So if you execute this, you now get a diagonal matrix where the principal diagonal has the value of 4. I could also do the same thing for a 3 by 3 matrix, just simply by changing the number of rows to 3 and the number of columns to 3, and we get that diagonal matrix. The whole thing is you can also supply a vector to the X argument to populate the principal diagonal. So what do? We just simply write the diag function x equals a vector of, let's say, 10 and 1000. Then we specify the number of rows to be 2 and the number of columns to be 2. So if we go ahead and execute, you realize that these two numbers you provided have populated the principal diagonal. So if you wanted to create a 3 by 3 matrix of a sort, then you could go ahead and do the same thing by providing 3 numbers to the X argument. Let's have 1, 2, and 3, and then n row equals 3, n call equals 3. And if you execute, you would also have your 3 by 3 diagonal matrix where the principal diagonal is going to be the 3 elements which you provided to the X argument. For all that we have done so far, let's go back to the documentation on the matrix function. We are now going to use the dim names argument. Now, if you scroll down the documentation page, you'd observe that we also have the title, arguments, and an explanation of the various arguments. So for example, the data argument is an optional data vector, including a list or expression vector, non-atomic class R object. Well, sometimes you just simply need the very first sentence or the very first phrase to know exactly what this argument is all about. So as a beginner, if you are not comfortable with what this actually means, don't worry. That is why I am here. So n row is simply the desired number of rows, n call is the desired number of columns. We have gone through that, but most importantly, we are now looking at the dim names argument. Now, that is a dim names attribute for the matrix. It is null or a list of length 2 giving the row and column names respectively. An empty list is treated as null. Okay, let's start demonstrating what this is all about. So I am going to create a matrix where I would specify, so let's go ahead and break it down this way. So data equals 1 to 4. Remember, that is also how we create a vector, 1 to 4, sequence of numbers from 1 to 4. N row equals 2. If I actually don't specify any n call, you would know that there are 4 numbers for the data argument. So the number of columns, R will figure it out to be 2. So don't worry about that. Now let's specify the dim names argument and then we set it to null. Why null? Because 1, the null is the default argument value. Like here, dim names equals null. So if you go ahead and execute this, you will end up getting your 2 by 2 matrix populated by the numbers that you provided to the data argument. But again, let's copy this code and I want to show you something else again. So if we go to the explanation of the arguments, you would observe that an empty list is also treated as null. And we have learned about lists in the previous video. So we just simply say list empty, don't provide anything. If you go ahead and execute this, you get the same result. But if you have a list of length 1 that will be provided as the row names. And if you have a list of length 2, that would be the row and column names respectively. All right, let me show you something here. Now, let me just pass X here as an object name, and let's create a list of 1, 2, 3, and 4. Execute and print the X, and you realize that each value is given its own list. But there is a function called the length function, and this length function will count how many lists we have in the list object. So let's pass into it the X which we created for the list and execute, and we get 4 because there are 4 lists. Exactly. If I also create X is lists of, let's pass just a vector 23 and 5, execute and print X, we have just simply one list, and that list contains 2 items. But let's go ahead and run the length function on X again, and we get 1 because there is only one list. So exactly, if you pass a list of length 1, that would be the row names. That is what we mean. So just simply pass some names as the only list using the list function, and then you'll be getting the row names. So let's go ahead and show how that is done. Let's copy this code and bring it down here. And now what I want to do is, let's execute the code once more. So we have our 2x2 matrix. You realize that the row names for this matrix is just simply the square bracket 1, comma over here. And then we also have the 2, comma. Now, we will explain this in great details when we get to accessing rows and columns of matrices, which is coming up for the next lesson. So at this point, I just simply want to replace all these square brackets that we have here, identifying the rows and the columns, using the dim names argument. So if I provide the list of length 1, I am going to populate the row names. So let's go ahead and break this list function down here, and within it, let's pass a vector of, let's actually call it row 1 and then row 2. And I'm providing these characters, only 2 characters, because there are 2 rows. So if I now go ahead and execute this code, you would now observe that my row names have been named with the ones that are supplied to the dim names argument inside of that list. So this is how you can also name your rows. And if I wanted to go ahead and name the columns, then I should be able to provide lists of length 2. So in that case, we have a list of length 1. I will just say comma, enter, and I will now supply another vector with character names where I can now pass the names for my column. So I will say column 1 as a character and then column 2. And if I should go ahead and execute the code, now I do have something that is looking very close to what we normally see when we are dealing with data sets. Now, let's create a matrix, a sophisticated matrix with row names and column names, much more intuitive one. So at this point, I am going to save the matrix I'm going to create into an object called A. Let's use A. So just like we are creating a matrix A, and I would now write my matrix function, enter. So within it, I'm going to specify the various arguments to create the matrix. So let's pass the data argument first, which is going to contain a set of numbers. So let me just provide some arbitrary set of numbers. Okay, so how many numbers do we have here? We have 4, we have 8, and we have 12, right? So the number of rows, let's set it to 3, and the number of columns to 4, because if we want to create a matrix with a dimension, 3 by 4 will do. Actually, the dimension m by n, like over here, 3 by 4, just multiply them together. So 3 times 4 is 12, and we have 12 elements, and that is how you would populate your matrix with 12 elements. If there were not 12 elements, and let's say there were only 10, which I've highlighted this way, then it will recycle over to complete the 3 by 4. But rightly so, we have 12 elements, and so we can create our 3 by 4 matrix. Now, most importantly, we are going to now write the dim names argument. So dim names equals list And then let's break it this way. So within the list, I will now pass a vector of names I want to give to my row names. So let's simply have alpha, and let's say beta and gamma. These are the Greek letters. And I supply 3 characters because we have 3 rows. Now for the columns, another vector with character names. Which one should we even use? Okay, north, south, east, and west. Really good. So at this point, let's go ahead and execute this code. And now we can print the matrix A. And what do we have? We have a 3 by 4 matrix where the row names are given by alpha, beta, gamma, and the column names are given by north, south, east, and west. So this is how you can create matrices in R.